Okay, so here we just want an introduction of what is linear algebra. Right, so this is not another algebra class, right? Even though it has the title algebra in there, it's not algebra in the sense of what we have been taught up or have learned up to this point. Right, so kind of the main goal here of this video is just to kind of introduce you, get you thinking about what exactly this class is going to be going over, right? And one way to think of this is we are going to be looking at systems, their structure, and the relationship. Right, that they have, right? So here we've all probably solved a system of equations before in an algebra class. Right, and again, what that is, you're not solving one equation, but the idea is that you're solving multiple equations, right? Probably just two or three, really, at an algebra level, and we're solving them at the same time, right? So we have a simultaneous solutions. All right, we were able to describe those solutions of our system of equations, right? Now here we're going to focus on the linear part, right? Now, when we say linear, right, we don't necessarily mean a line, although it can be if we're dealing with equations in two variables, right? Our two variables there, then that graphically would be a line, right? But for more variables, other variables, 2 or 3 or 4, right, then that line concept really doesn't geometrically follow. When we're dealing with 3 dimensions, we're looking at like planes, right? But that is still defined as linear, right? So linear in the sense that all of our terms, right, have one variable, and that variable is to the power 1. All right, now here, as we can see here, we have a picture here of some planes, and right, these planes, each one of those planes represents a linear equation, right? And again, linear in the sense that in 3 dimensions, right, the plane is described by an equation involving an x, y, z, or x1, x2, x3 is the convention we'll use in this class, right? But as you can see here, when given 3 planes, right, then, excuse me, there are a variety of things that can happen. Well, sometimes they can all be just a different equation, looks like a different equation, but it's actually describing the same one, right? They intersect across a line, maybe they're parallel, right? And here, if you look at 2, they 2 coincide. 2 of them are the same, but the third one cuts through the other 2, right? And then here, 2 parallels and 1 intersecting, all 3 parallels, etc. All these are solution types, right? So they all are describing what can happen, right? Here we can see them visually, right? And if you notice here, right, there's really 3 possibilities, even though there's a variety of graphs here. There are 3 things that can happen, right? The first one, if you look at number 6, is that they all meet at one point, right? That is one solution, all right? The other thing that can happen, if you look at 5 here, is that all 3 are parallel, so there is no intersection, so there's no solution. All right, and then the rest of the instances here are this idea here where there is an infinite number of solutions, right? Actually, 8, there's no solution because all 3 of them don't have a corresponding one. But the other ones here, right, like 1, 2, and 7, those correspond to infinite number of solutions, right? And 4, 5, and 8, those correspond with no solution because that's not satisfied all 3 at the same time, right? Remember, we're talking about simultaneous solutions, right? So that's kind of an idea of what we will be doing in this course, right? We'll be taking a look at these systems, their structure, and how they're related, right? We're solving simultaneously these systems. So there will be some computations for sure. So we're going to focus on computation, right? Explanation, and then justification. Right, so we will build up towards being able to write some basic proofs. All right, and now we will build up to that, right? So we're not going to be doing that right away, right? Now, as you get started here, the best thing that can help you out here is, right, I feel like the computations should be done. Those shouldn't be too challenging. It should be something that is very approachable. But what will help you start building in your success in this class is just understanding sets, understanding solution sets. Knowing when systems are equivalent, right? And again, the upcoming videos will get into all of that. Knowing when systems are equivalent. And being able to explain your reasoning, right? That's going to take you a long way, right? Not necessarily with the rigor of a proof, but being able to, using your words to explain your reasoning, right? Why you are doing something. Okay. All right, so here, as we move forward again with this linear algebra, right, we are looking at being able to do some computations, explain and justify our solutions.